This is what we call the all-purposes power supply. Starting from the input, there is a three-phase magnetothermal differential switch for protection of the unit and of the people using the unit. Once that the unit has been powered on, and these are the commands, there is a key that allows use of the unit by authorized people only, some controls like start and stop, emergency off, and an indicator for signaling that the line is present. From the input, there is a distribution, a three-phase output, fixed output, a three-phase variable output, and it is varied by means of a three-phase variable auto transformer, a DC high power output, variable by means of the same command. This is high power to be used for powering DC machines, and a low power DC output for powering excitation windings of synchronous machines and DC machines. You can see that each output has its own ammeters and voltmeters. In case of the three-phase variable output, there is a selector that allows selection of DC voltages, both phase and star voltages. We have here another kind of power supply, a very simple one. This is a single-phase variable supply. You see, again we have a single-phase variable auto transformer. We enter with an AC, we can exit with a variable AC, and also with a variable DC. It's very handy and in certain applications very useful as well. We are now going to perform an exercise taken from the manual. These are the actual pages of the manual that will show you how the manual is organized. The exercise is first of all described in terms of its objectives. Then there is a theoretical review which recalls the main formulas related to the test itself. Then it suggests some of the components necessary to go through the test. Then it shows the theoretical diagram of the test itself and the actual practical setup of the test with the power supply that we have seen previously, the machine under test. In our case we have a squirrel cage motor driving a synchronous generator, and the objective is to draw the characteristic of the generator by drawing the output voltage against the excitation current. As you can see here, we feed the motor coaxially connected to the synchronous generator, where we measure frequency and voltage on the output and current and voltage on the excitation. Now I'm going to show you the actual test. Okay, now we are going to do our test. First of all, we need to power on the machine, the power supply, and our instrument. Then we give power to the driving motor. This is a 230 400 volts motor, and I have selected the face-to-face voltage here, so we will read here about 400 volts. When we are at 400 volts, the motor is running at nominal speed. At this point, we now need to give excitation to the synchronous generator. I give excitation. Now, they are going to measure voltage and current of the excitation on these instruments here. As you can see, excitation, nominal excitation is 220 volts, and current is about 0.6 amps, which is the nominal, are the nominal values. We have executed a test, and the execution is described in the manual. Here I have presented the results of the test. There is a table with the actual values of currents and voltages, and the graph of the result. The graph shows the relationship between excitation voltage and current of the synchronous generator against voltage output. We have reached the end of the presentation. I hope you enjoyed it, and above all that you find it useful. Should you need to order a laboratory, I suggest that you consult the ELECTRON catalog, where you will find a total list of equipment, and from which you can choose those that fulfill the configuration required for your specific laboratory. Thank you very much.